All right, so here is Laws of Exponents number 4 and number 5. I know you're like, Miss Haynes, I am so sick of these exponent rules. But we're done with these two. This is it. So the first one's called the zero power. And the zero power is so simple because any number to the zero power is going to be 1. So if I have x to the zero power, guess what? It equals 1. If I have 5 to the zero power, guess what? It equals 1. And say I have something like 3 squared over 3 squared. Well, so our exponent rule for the quotient property would be to subtract the exponents. So 2 minus 2 would give us 0. 3 to the 0 power is 1. Now, how did we get that? Well, 3 over 2, or 3 to the second power, divided by 3 to the second power, is really just 1, because any number over itself is 1. So the 0 power always equals 1, okay? The next one we're going to take a look at is the negative powers. And in math, we only like the powers to be positive. So this one can be a little bit tricky. If I have x to the negative 1 power, that's not in simplest form, okay? So we want to make it in simplest form, and to put it in simplest form, we would need to make it a positive power, okay? So to make it a positive power, you're going to switch whichever base is to the negative power to the opposite spot on the fraction. So here's a fraction, right? And a is in my numerator and b is in my denominator. So right now, x to the negative 1 is in the numerator spot of that fraction. It's where the a would be. So I'm going to put it where the b is, okay? And I'm going to make it a positive power when I do that. So if I make this into a fraction, I said I'm going to put it in the denominator and make it a positive power. So what do I have to put in the numerator then for this one? I have to put a place value holder of a 1. So this is the general rule for negative exponents, okay? So if I have x to the negative 1, in simplest terms, it would be written as 1 over x to the 1. Do I need that 1? This one? Not necessarily. Okay, I could just write it as 1 over x. So let's take a look at a couple more examples. We'll progressively get a little bit harder. So say I had the fraction 1 over a to the negative 2. So the rule is to switch the base, so the base here being a, that has the negative power, to the opposite spot in the fraction. So it's in the denominator, so we need to move it to the numerator. So we need to switch it to the top. And so when I switch it to the top, I get a to the second power, it makes it positive, times this 1 that's up here. Well, a squared times 1 is just a squared. Okay, so let's look at a harder example. Say I have 3 over 2 to the negative 3rd. Again, the base that has the negative exponent is in the denominator. So I want to move it to the numerator. In the numerator, I already have a 3. So in this case, I'm going to have 3 times 2 to the positive 3 now. Now, this can be simplified. Okay, 3 times 2 to the 3rd power is 2 times 2 times 2. So that comes out as 8. And then 3 times 8 would be 24. So that would actually be in simplest form. Let's look at another example. Okay, so we have an example here where both the numerator base is raised to a negative power and the denominator base. So we're going to flip-flop these two, and I'm going to write it as 3 to the third over 3 to the second. Is that simplified? Nope. We have a quotient rule here, so I need to simplify this further. And the quotient rule, so the quotient meaning divisor rule, would be to subtract the exponents. So 3 minus 2 is 1. So there's my new exponent. 3 to the first power is 3. All right, so I have 4 to the negative second power and 2 to the negative third power. These are two different bases. So in that previous example, both had 3's, but this time we have a base of 4 and a base of 2. Does it matter? No, we still want to make them positive powers. So in this case, we're gonna flip-flop both of them because they both have a negative power. So 2 to the third would be on the top now, and 4 squared would be on the bottom. Now, like in the previous example, we had both 3's here. We had 3 to the third and 3 to the second. So we could use that quotient rule where we subtracted exponents. In this example, we can't do that because we have two different bases. We have a 2 and a 4. So the first thing I'm going to do is simplify them. 2 to the third power is 2 times 2 times 2, so I get 8. And 4 to the second power, or 4 squared, is 16. So I get 8/16 or 1/2. So that would be our simplest term. All right, let's look at a few more examples. Say I have this example. This one's a little bit harder. I need you to really look at this and decide where the negative exponent is and where it should go. Okay, so here's my negative exponent. The 4 doesn't have a negative exponent with it. The x does. Okay, so the 4 stays in the numerator. In the denominator already, I have this x, so I need to copy it down. It's not a negative x, so I'm not going to put it in the numerator. And now I'm going to be multiplying it by this top numerator x value that has a negative exponent. I'm going to switch it to a positive exponent and put it in the bottom, or put it in the denominator. So what do I have as my simplest form here? 4 over, and now we have x times x squared. So this is our multiplication power rule. And this first x has an imaginary 1. So 1 plus 2 is 3. So that would be my final answer. Okay, hopefully you took notes. Upload them to the assignment.